Okay, so we talked a little bit about the different types of roles that make up machine learning teams. And the next thing I want to talk about is how machine learning teams fit into the broader organization. So a couple of lessons that we've learned from the conversations that we've had with companies about this right off the bat. There is not really a consensus yet on what is the right way to structure a machine learning team. But the goal of what I want to cover right now is just to give you to try to give you a taxonomy of what some of the best practices are for structuring machine learning teams as your organization gets more and more mature in terms of its machine learning capabilities. All right, so the metaphor I want to use here is the machine learning organization mountain, right? So we're going to start at the base of the mountain where companies, they've never even heard of machine learning, and they're like, what is a deep neural network? And then they're going to climb up to the top when they become Google. So I think the starting point for most companies is that that machine learning is ad hoc and they don't really have a function. And so this basically looks like there isn't really anyone doing machine learning in-house, or maybe there's some people who have some affinity to machine learning, but it's not their full-time job. And so I think most small to medium businesses sort of fit into this category right now. And I think even larger companies, a lot of less technology-forward companies are in this category as well. They really have not formalized machine learning at all. I think the main advantage, if you happen to be in one of these organizations, is that there's often a lot of low-hanging fruit. Right, to Sergey's point, if you just go sit with a line of business and you figure out what problems they have, you can train simple prediction models that can often make a big difference. But there's a huge challenge here, which is that there's often sort of very little support for machine learning projects, and that can mean both infrastructure and compute and sort of leadership buy-in that this is important, which matters when you have projects that follow a different sort of timeline structure than typical projects do. And it can be hard to get really talented people to come and do machine learning at organizations like this. So I was alluding to this earlier, but I think often the next step that companies take when they're like, the market speaks and the market tells them, you need to have an AI strategy, right? I think the natural thing for a lot of big companies to do is to build machine learning into their R&D function. And so, this is maybe you'll have a handful of researchers or PhDs that sit in your R&D team, and they, basically take data in from the business and they write papers. Maybe those are publicly facing papers, or maybe they're just internal. And so I think from the organizations I've talked to, a lot of the larger oil and gas companies and manufacturing companies fall into this category. One of the big advantages of doing things this way is you can often hire sort of more experienced researchers to do this, because a lot of experienced researchers love to kind of sit in the ivory tower and look at a bunch of data and just produce models and not really worry about what happens to the models after that. So this kind of thing can appeal to people like that. And another big advantage, I think, is since you're sitting within R&D, you're sort of less beholden to the near-term timelines of the business, and so you can work on sort of bigger picture, longer-term things. But I think this usually fails for most organizations, and there's a couple of core reasons why. The first is that it's very difficult for a lot of these R&D groups to really get data from the businesses, right? Because it takes work for the business to give them the data, and if they're not seeing the value of the models that the R&D group is training, then they're going to be hesitant to really work closely with them on it. And so I think usually the amount of investment sort of remains small because it's hard to see real wins in terms of business value. The next kind of logical step that most organizations seem to take is to embed machine learning into business and product teams. And so this would mean you have a product team and you realize that hey, there's actually an ML problem embedded into this, right? ML would help us make this product better. And so you'll bring in an ML engineer into the team, and that ML engineer will report up to the tech lead or to the engineering lead, and they'll sort of work on embedding machine learning into the product. And so I think this is I'm seeing a lot of kind of more medium-sized software companies that are like this, and a lot of financial services companies as well. And I think to the point that Sergey raised earlier, this can be really great because you see a very clear connection between the work that the ML team is doing and real business value. And so that means that you can, like oftentimes it'll be easier to get more and more investment into machine learning. And also you have like a very quick feedback cycle between idea and product improvement, right? So you have an idea and then the machine learning engineer on the team can just sort of prototype it and see if it works very quickly. That being said, there are a number of disadvantages to this model as well. I think the core disadvantage of having machine learning dispersed throughout the organization is that it's just really hard to invest in things that make the machine learning as a function better, right? So it can be hard to hire and develop the best people, because I think a lot of really ambitious and great machine learning people want to work with other ambitious and great machine learning people. And so if they're kind of one ML person inside of a broader business function, this can be a hard sell. And I think also to the point that one of the questions raised, this can make it harder to develop top machine learning people because they're sort of the only person or one of the only people doing their job within their team. But I think also this can sort of harm the ML projects in terms of access to resources, so to data and compute. And I think this is also sort of where the discrepancy between machine learning project cycles and engineering project cycles tends to rear its head the most strongly, right? So I think a lot of times engineering leads will conflict with the ML people on their teams because they're not sort of delivering reliably and fast enough. And then I think also, one challenge here is that the flip side of being able to deliver business value through machine learning projects is that oftentimes it can be more difficult to justify investments into projects that would require a ton more effort and longer timelines. So I think where a lot of organizations sort of move to after this is they build an independent machine learning function within the company. And the distinction here between this and sitting within R&D is just how senior of a person your lead ML person reports to. And so a lot of times the head of AI or the head of data scientists will report up to the CIO or the CTO or the chief data officer or even the CEO. And so these teams often have a mix of skill sets like ML engineers, ML researchers, and data engineers. And then those folks work with ML PMs who sort of form the link between the central ML function and the business units of the organization. And I think the one category of companies that I've seen that's doing this a lot is the larger financial services companies. The advantages here are, since you have talent density, right? So since you have one team that has many of your ML people, you can hire great people, and you can train great people, and you can invest in the things that those people need to be successful. So you can build tooling, you can build a culture around machine learning development and deployment. Another advantage is that since the reporting line of this group is usually pretty senior, they can help get access to data and break through some of the barriers that more R&D focused machine learning teams have around working with the rest of the organization. But I think the core disadvantage is that these teams typically have to hand off their work products between themselves and the rest of the organization. So they have to get data in, and then they need to hand their model off to some user. And the challenge is that those users, if they themselves are not sophisticated machine learning practitioners, then it may be hard for them to actually operate the model because they may not have sort of the mental frameworks for thinking about where the model does and does not apply. So handing off the models to users becomes sort of a central challenge for centralized machine learning teams. And then I think the final state in the evolution of the ML team is the ML first organization. And so this is like ML permeates your organization. The CEO is totally bought in. We're an AI first company. You have a centralized ML division that's working on the hardest problems that your company faces. And then every line of business has ML expertise built in. And I think there's not that many organizations in this category. Google and Facebook are in this category, and then some ML-focused startups are in this category as well. And so if you can do this, this is, I think, the end state for where most organizations will try to go, because you have great access to data, sort of combines the advantages of having ML embedded in the lines of business and having a centralized ML team. Right? Great access to data, but also the ability to deploy things and to mentor talent in the central ML function. But I think the main challenges are that this is just really hard. Right? It's hard to implement it. It's hard to recruit enough people to make this work. And it can be culturally difficult to shift an organization over to this mindset. There's a few design choices that machine learning teams face when setting up the skill sets on their team and the culture of their team. So one of them is software engineering versus research, right? So to what extent is the machine learning team responsible for building or integrating with software? Right? So is the ML team really just doing research? Are they really just training models? Or are they also building products that use those models? And relatedly, how important are software engineering skills on the team? There are also some questions around data ownership. How much control does the ML team have over data? Right? So is it the ML team is responsible for collecting, labeling, and managing its own data, or is that all the responsibility of some other line of business? And then lastly, model ownership. Right? So is the ML team itself going to deploy models into production, or are they going to hand them off to someone else to deploy into production? And relatedly, who maintains them? And so here's kind of how those team structures map against those design choices. So in ML R&D, oftentimes research is prioritized over software engineering skills, and there's relatively little collaboration between researchers and software engineers. ML team often has very little control over the data, so they get a package of data in and they train models on that data, but they don't have any influence over how the data is collected and stored. And they often won't have any sort of data engineering function at all as a result of that. But none of that really matters because the models themselves are rarely ever deployed into production. Embedded machine learning teams. I think here you kind of see the opposite. So software engineering skills are often prioritized over research skills. And you'll hear people say things like, I would never hire anyone who is a machine learning researcher who can't write production-ready code. And here, often also the machine learning team doesn't own sort of data and pushing things into production, but they do work closely with data engineers on the teams that they sit with to build data pipelines. And then ultimately, typically the ML engineers that build the models are responsible for owning those models once they've been deployed into production. If you have an internal ML function, then that function will typically have a mix of software engineering and research skills. And so that means that you don't necessarily need every single person to be a great software engineer and a great researcher. But it does mean that you need those folks to work closely together. One of the advantages of this team reporting to someone relatively senior is that they have a voice in data governance discussions, so they can help the organization decide how data is broadly captured and managed, which can help them build better prediction models on top of it. And these ML teams themselves usually have pretty strong internal data engineering functions. But when it comes time to deploy the model, they typically hand it off to a user who is responsible for operating it, but maybe not maintaining it. And then finally, in ML-first organizations, there's different teams that have more or less research orientation, and there are some teams that might be almost entirely researchers that collaborate closely with software engineering teams. And they're able to do that because there's sort of a shared understanding about how ML works. And so the ML teams don't necessarily need to be great software teams themselves. The ML team in these organizations is actually often responsible for the entire company-wide data infrastructure. And they're able to hand off models to users who both operate and maintain them. And so this is all of that stuff on one slide. Any questions about sort of how ML teams are structured, how they fit into organizations?
Which part of the mountain do you think would be a sweet spot for machine learning engineers?
Yeah, it's a good question. I think what you should figure out is, are you motivated by sort of making stuff that makes products better, or are you motivated by solving really hard, interesting technical problems? And if the thing that gets you up in the morning is saying like, yeah, I want to improve our company's product by 1% or by 10%, then I think being embedded in a function is great, because that's the highest likelihood that you'll actually do that. I think if you're more motivated by like, yeah, I want to use like great tooling, and I want to work on problems with huge data sets where we can try state-of-the-art models and really try to push the envelope, then I think it's much better to be in a centralized ML function, because you'll have more support to do that.
Since there are so many things that can be learned in machine learning roles, what do you think is wiser? Trying to focus in specializing in, for example, NLP or vision, or being more of a generalist?
Yeah, again, I don't think there's a one-size-fits-all question here. I would focus on something, right? I don't think it's always a great strategy to be a total generalist. Like, I think it's good to have some sort of specialization.
Unless you start a startup.
Unless you start a startup, yeah, that's a good point. But I think your specialization doesn't need to be a particular subfield of ML. It also could be you specialize in building really good data pipelines, and you learn how to build really good data pipelines for NLP and for computer vision and sort of every other ML subfield. So I think you can go deep in something without picking a subfield of ML if you want to.
Yeah, I don't understand this question, but maybe you do. Do you have an opinion on the state of academic space? For example, what is happening to computer science, math, and statistics departments as a result?
I think this question is a leading question that's meant to make me say, machine learning research departments are being drained by industry, and there's no great researchers left in academia because they're all getting sucked up by Google. I think that's what whoever asked the question wanted me to say, but I don't totally agree with that. I think there are still a lot of great researchers in academia, and I think for the most part, the relationship between academia and industry right now in machine learning is pretty healthy. I mean, it's not perfect, but I think that for the most part, machine learning researchers that go to places like Google are still publishing research, and they're still able to mentor students and train the next generation. But they also have access to much larger set of resources to do their research, right? And in machine learning, especially in like state-of-the-art machine learning right now, having access to a ton of compute is just so important. So I think for the most part, it's a pretty symbiotic relationship.
Is it better to get a PhD in math or in computer science?
Computer science. Next question.
So typical progression, career progression is like junior does technical tasks, and then manager does more external communication and management. Is that similar in data science and machine learning?
I would say broad strokes, yes. But I don't think that's always the typical career path. I think that there's, for example, like you can go be a really senior machine learning researcher at a university or a place like Google and still have most of your time be working on individual contributor stuff.
And then someone asks, should there be a machine learning testing position?
Maybe, yeah. I think it's worth thinking about whether there should be a position that's focused. Maybe I wouldn't phrase it as testing, but I think like bias is becoming a bigger and bigger and more important area of focus for a lot of machine learning teams. And so I think it's very possible that for more mature ML teams, it's worth having someone who is responsible for making sure that your team's models are not producing biased predictions.
Do you have any information? What would you say is the balance of supply and demand for all these roles?
Yeah, I think for most of these roles, there's a lot more demand than there is supply. I think maybe, yeah, I think it's like it depends on where you're sitting, right? I think for a lot of people who are coming from a very let's say prestigious company like a Amazon or a Facebook or something like that, it can feel like there's just way more demand than there is supply. I think it's still on the flip side, it can still be hard to break into the field, and I think that oftentimes, since people don't really know exactly what they're looking for from a lot of these roles, a lot of these roles are still pretty nebulous. People sort of fall back on prestige as the way of measuring whether this person is good or not. So I think the flip side of that question is there are a lot of people who are trying to break into the field and are having trouble doing it. So there's a bit of a tricky balance there.
There's a very specific question about an attendee's son.
Okay, I'm gonna move on in that case. It's good. Yeah. All right, so I want to talk about how to manage a machine learning team. I think kind of maybe the key point here is just
actually, there's a really good question.
Okay.
Have you personally ever had imposter syndrome?
Yeah, I definitely. I mean, I think well, there's a question about math PhD versus computer science PhD. When I came to Berkeley, I was in the math PhD program, and I decided very quickly my answer to that question, and decided I was going to try to switch into the computer science program and work with Peter. And early on, it just felt like I barely knew how to program at the time. This is a really crazy idea in retrospect, but I was like, I'm just going to go for it. And so I was sort of teaching myself Python and trying to keep up in all these grad classes when I hadn't taken the prerequisites, and then also sort of trying to make trying and miserably failing to make progress on research. And yeah, and most of the people in the program were just Berkeley often gets sort of the best AI PhD students, and so I just felt sort of hopelessly behind where most of those people were, and I felt like it might be hopeless to try to catch up. But my attitude was just yeah, I mean, if you're in an environment where everything is really hard and you have to really devote yourself 100% to even keep up, then that means that at a minimum you have to be learning a ton, right? And so I was like, yeah, the worst case is it won't work out. I'll the math program will kick me out because I'm not keeping up with my classes there, which they threatened to do, and then I'll go get a job, but I will have learned a ton of machine learning. So yeah, I think most people face this at some point, and I definitely have. And I think it's it's in some ways it's a healthy thing because it's motivation to really keep working hard and try to push through it.